Hello, students. I hope everyone is doing good. And we are moving to the next topic in the distributed systems. Today's session is specially, we are concentrating on the operating system concepts. Those are process, thread, multi-threading, and virtualization. So let us move in detail into this. The outline which we are going to discuss, as we have mentioned just now, that is process, thread, multi-threading, and virtualization. Right. So first of all, what is a process? See, a process is a program under execution or else an running application. So everything, whatever which is under execution point of view is called as a process. Right. So for this, what will be the memory spaces? So we'll be having the stack space over there, heap space, and the data space. See, where in the stack space, we'll be concentrating on the function calls or the parameters which we are calling on the function, or else when we are moving from one procedure to the other procedure. So how we are maintaining the forward and backward movements of that particular procedures will be stored in a stack space. Heap is, as we all know, this is a dynamic memory allocation where all the node structured data which are dynamically allocated at runtime, we will be storing all these kind of node structures in the heap data structure. And the data space is nothing but the variables which we are initializing while we are utilizing in a program will be stored in the data space. So all the integer a, so a is a data variable. So that variable we are going to store in the data space, right? So these are about the memory. Now coming to execution point. So where the process can be executed. See, the process will be executed in a system by calling with respect to the PC. So a program counter will be there. So after which process has to be executed, and there will be a stack pointer from which process to which pointer we have to move on, and there will be data register. Along with this, we will be having code data and stack data to be maintained onto the execution, I mean the space allocation. And also when we are executing, what are all the requirements we need, we will be having all those instances in the process, in the operating system, right? And along with this process thread, we will be also having the virtual space virtualization here. So virtualization, in the virtualization, how we are going to allocate the virtual address, right? How we are going to execute with respect to the virtual spaces. So everything will be in the point of the process. Now, process will be having a process table, process allocation table, where all the metadata of the process will be available. As we all know, when we have discussed in the operating system, we have known all the process allocation table in depth with the unique identifiers, and also what are the variables we are going to utilize, how the priorities will be set. All this we have seen in the operating system, right? Now, what is a thread? Thread, as we all know, that is a lightweight process. That is a part of a process. Right. So a part of a process is nothing but a process. If it is an application, in that application, a unit of execution of that particular application will be called as a thread. Now, a thread and a process and multi-threading. So there will be a minor differences between all this. A process can have n number of threads. So that is nothing but multiple threads can be possible. Now, always a process will be only one process. And when we are executing one process, we need a separate space for that process. When we are executing threads, all the threads will be sharing the same process memory, right? Because a part of process is a thread. So all the threads, if a process one is having 5 threads internally, all the 5 threads will be utilizing process one's memory, right? So how to execute within the process as a multiple threads will be in the next session. When we are running a thread and a process, we will be knowing all those. And now, how the CPU utilization will be done by this several threads. So that is simple by sharing the resources properly. So resources are nothing but the CPU utilization and also the memory, and everything comes into the execution pointers. I mean the where we are executing exactly. So all this will be in the process and thread. Now process versus thread. See, process versus thread means a process is a whole application. Now a thread is a unit of that application. Now process can have one or more threads, and process itself is one process only, right? Now coming to the inter-process communication in the process, as we need a lot of memory because every process needs a separate memory allocation, right? Memory space required for P1 separate, P2 separate, P3 separate. So here inter-process communication, when we are switching from one process to the other process, one source to the other source, the expense, it will be very expensive, right? So that's the reason compared to inter-process communication, compared to the inter-process communication in the process and the thread, process will be expensive and the thread will be cheap because thread will be sharing the existing memory of the process. So it doesn't need many threads may not be needed extra space to execute somewhere. So one process, if one process memory is available, all the threads will share that memory. And there will be no context switching in. Thus, when we are discussing about the process, one process cannot change other process data. So that is what it is highly secure. Coming to the thread will be, one thread will be having the access to write or read on the other thread also. So thus, this is not secure, right? So this is all about the process versus threads. Now, threads in the distributed system. So threads in the distributed systems, it's an important property where we are going to discuss about few system calls. So because threads in the distributed systems means there will be n number of systems. All the systems must be coordinated with the thread concept because we are running one application. So all the threads will be somewhere available in the distributed system. So how these threads will be communicated with each other. So for that purpose, we need system calls. So system calls will be given to that particular thread so that with the logical connections at the same time, all the threads can be activated and one after the other, all the threads can be executed. So that is what the main importance of threads in the distributed system. And here, a thread may be a client, a thread may be a server, and the communication or processing or else everything will be possible in the threads in the distributed system. So when we say multi-thread client, so the best example which we have stated here is a web browser. So always a client will be as a user, we will be communicating first, initiate our request with the browser itself, right? So multi-thread server means the main server which is giving the resources or responses to the client. Okay, so this is multi-threaded client and the server. So when we say client and server, as we have just discussed, always initiation procedure will be taken by the client. So there we need the web browser kind of things. So web browser will be having several threads internally like HTML, and then from there we have to go with the HTTPs and all animations, applets, everything needed, right? So that is a client perspective. Coming to the server perspective, what is the main agenda is to work for the client. So that is nothing but we call multi-threaded server as dispatcher worker model, right? Because once we get one request, immediately we have to work on that when we have to dispatch our output to the client. So that's we call dispatcher worker model as we have stated here. See, once we have received one request from the network, then dispatcher thread will be activated and all the threads, worker threads of the server will be working on that particular thread to give the output back to the client. Okay, so coming to its types. So single-threaded, multi-threaded, and finite state machine server. Single-threaded is very simple that at a given single moment, one thread will be executed sequentially. Multi-threaded means concurrently we will be executing n number of threads. Now, finite state machine. So finite state machine is nothing but when an event occurs, immediately all the states. So states, as you all know in the format automata theory, formal languages automata theory, you will be having states and state diagrams and all, right? So here FSM, state finite state mission, will be saying that all the states or events which are taking place, processes which are taking place, must be finite. Okay, must end at one place. It should not be infinite, right? So one after the other parallelly, we have to go and execute with the systems, right? And next, model and the characteristics of this particular server. So the characteristics are nothing but when we are applying the parallelism, I mean, when the threads will be executed parallelly, and when the threads are going to block the system calls. Because when I'm executing, when I'm getting the other system call, that thread should not be activated unless until I complete this one, right? So there we need some blocking system calls. So thus we have constructed in three ways. First one is the blocking system call, that is threads parallelism. Okay, so parallelism means we have to execute all the threads. So thus we have to block few system calls. Single threaded means it's a simple one after the other. To give a better performance, we will be blocking the system calls, because when one is executing, we should not accept the other one. Finite state machine, it can accept n number of dynamic data. Okay, one number of dynamic data which are coming, but we have to end at one finite state, right? So this is what the process, thread, and multi-threading. If you have any doubts till this point, please be free to contact anytime through comments or directly in the college. Thank you for listening.